So we're continuing our exploration of solving two-step equations. We started off with basic two-step equations. Now we're moving on to solving them when we have variables on both sides. So if you look here, we've got 13x on one side of the equation and 11x on the other side of the equation. And that, we can't really solve that very easily unless we adjust that. So I'm going to show you how to do that. So the way that we do this is by getting all the x's on one side, and that's the same way we do it if we were trying to get all the constants on one side. We're going to subtract 11x from both sides. This would work if I subtracted 13x from both sides too, but I would prefer to end up with a positive number in the end. In this case here, what I end up with is 13 minus 11, so that's going to be 2x plus 9, can't forget the plus 9, is equal to 13. So now I'm just going to solve this the regular way. I'm going to subtract 9 from both sides. If I subtract 9 from both sides, I end up with 2x is equal to 4. Then I'm going to divide both sides by 2 because 2 times x is not what I want. I just want x. So I have to divide by the coefficient, the number in front of the x, because that's multiplication. And when I do that, I end up with x is equal to 2. For this problem here, same thing. What I've got here is I've got x's on both sides, so I need to move some of those to the other side of the equation. So what I'm going to do is, in this case here, I'm going to add 3x to both sides. When I add 3x to that side, this will cancel out. Add 3x to this side, I'm going to end up with 8x. So it's going to be negative 25 is equal to 8x minus 1. So now my next step is getting rid of that minus 1 so I can isolate the variable so it's on one side. So plus 1. It's going to isolate the variable. So it's going to be negative 24 is equal to 8x. So now I've got to divide both sides by 8. When I divide both sides by 8, I end up with x is going to be equal to negative 3. So that's kind of the pattern of how these problems work. I'll do one more of those later. But these two down here, these other two problems down here, they're special cases, so I want to go ahead and address those also. So what I have here is I've got to deal with this distributed property in both of these before I can proceed to solving the equation. So let's look at this. I've got to go ahead and multiply, get rid of the 6 by distributing the 6 to the 1 plus 5y here. So 6 times 1 is 6 plus 5y. 6 times 5 is going to be 30y. That's going to be equal to 30y minus 2. Okay, now my problem is this, that I'm trying to get them so they're on the same side of the equation, so I'll subtract 30y from this side. If I were to do this, what I'd end up with is, I'd end up with 6 is equal to negative 2, because this cancels out and this cancels out. That's not a true statement, so in this case here, there's no solution. And I want to let you know also that the color of the day is aquamarine. Aquamarine. And if you don't get the spelling right, that's fine, but try and spell aquamarine in the question in the form. It's just a way of making sure that you're following along as well here. So in this problem here, what we've got is negative 14 plus 7x is equal to 7 times x minus 2. And the thing about this one here is that if we distribute that 7, we're going to end up with negative 14 plus 7x is equal to 7x minus 14. So if I subtract 7x from both sides, what I end up with is, I end up with negative 14 is equal to negative 14. That means every number is a solution. because it does not matter what the value of x is. So it's every number is a solution. Every number solves this equation, because really these two equations are the same equation. They're just written a bit differently. And for this one here, just going back here, the reason why there's no solution on this one is because you can't plug in any value of y and get an answer, because the 6 is equal to -2. That's never going to be a true statement, no matter what value of y I plug in. Okay, so I'm going to do one more problem. This is going to combine a lot of elements here. Here I've got two sides of the equation. Both of them have x's on them, and both of them we're going to have to use the distributive property in. So over here, 3 times 2x is going to be 6x. 3 times subtracting 5 is going to be subtracting 15. That's going to be equal to -6 times x is -6x. And -6 times 1 is the same as -6, or plus -1, it's the same thing. So now what I have to do is I have to figure out which one of these sides I want to go ahead and get the x's on. So I'm going to do that by adding 6x over here, adding 6x over here. When I do that, I end up with -15 is equal to 0, or -15 plus 12x is equal to 0 minus 6, because this cancels out. Let me rewrite that out. That makes it a little bit easier to understand. So now I need to get to move this, and to do that I've got to add 15 to both sides of the equation. When I add 15 to both sides of the equation, this part cancels out, and then I'm left with 12x is equal to -6 plus 15. So that's actually going to be positive 9. You divide both sides by 12. When I divide both sides by 12, what I'm left with is x is equal to 9 divided by 12, so 9/12. If you really wanted to go all the way, it would be simplified 3/4. So that's how you do these problems. Make sure to answer the form, and remember what I said about the color of the day, and also remember that there's those 3 different possibilities, 3 possible solutions. There's the integer solution, that's a number. There's no solution, nothing that makes the statement true, and then the final one is going to be all numbers are a solution. So those are the 3 possibilities on any of these type of solving equations when there's variables on both sides.